exploring the concepts of physics using adorable animals, of course. Pebbles is up first. In this clip, Pebbles is enticed by a red laser to run across the kitchen. Using simple kinematics, we will be able to solve for our average velocity. She travels a distance of 2 meters in 2 seconds. The formula we will use to find the average velocity of an object is delta x divided by time. That's average velocity. So when you substitute the numbers into the equation, you have 2 meters divided by 2 seconds. Her average velocity running that distance is 1 meter per second. We can also explore the forces acting upon Pebbles. Due to the force of gravity, she exerts a force on the floor. As explained by Newton's third law, every action has an equal and opposite reaction. So the floor exerts a force back on Pebbles. This force is known as normal force. The force of gravity is equal to Pebbles' mass times gravity. Pebbles has a mass of 14 kilograms and gravity is equal to 10 meters per second squared. 14 kilograms times 10 meters per second squared equals 140 newtons. So the force Pebbles exerts on the ground is 140 newtons, and the force the ground exerts on her is negative 140 newtons. The forces cancel each other out, leaving Pebbles stationary on the y-axis. In the video, you can also see that Pebbles accelerates from rest and then decelerates back to a stop. When she ultimately decides to stop, the force of gravity is too weak to stop her, and she ultimately slides a little further. Silly Pebbles.
Kitty, who has a mass of 7.5 kilograms, is pushed from rest with a force that was applied for 0.1 seconds, causing her to fall for 0.42 seconds until she hit the ground with a horizontal displacement of 0.6 meters. With this information, it is possible to calculate Kitty's vertical displacement, horizontal velocity, and her velocity just before hitting the ground by utilizing the principles of kinematics and the conservation of energy. You can also solve for the force applied on Kitty to make her fall using the force formula. First, it is possible to find her vertical displacement by using the formula delta y equals initial velocity times time plus 1/2 acceleration times time squared. Since the initial velocity on the y-axis is 0, the formula becomes delta y equals 1/2 acceleration times time squared. You then plug in the appropriate numbers. Acceleration is 10 meters per second squared due to gravity, and the time is 0.42 seconds. You solve to find delta y to equal 2.1 meters. You can solve for the velocity on the x-axis using delta x equals velocity times time plus 1/2 acceleration times time squared. Acceleration equals 0 on the horizontal axis, so the formula changes to delta x equals velocity times time. Then, delta x divided by time equals velocity can be derived from that formula. Delta x equals 0.6 meters, time equals 0.42 seconds, and when you plug in those numbers, you find that the initial velocity on the x-axis is approximately 1.43 meters per second and is held constant throughout the equation. We would have been able to use the conservation of energy to determine Kitty's velocity before hitting the ground. Her potential energy on top of the island is equal to her kinetic energy just before hitting the ground. Potential energy is equal to mass times gravity times height, and kinetic energy is equal to 1/2 mass times velocity squared. When you set those two equally to each other, the masses cancel out, and you are left with gravity times height equals 1/2 velocity squared. Manipulating this will give you radical 2 times gravity times height equals velocity. Gravity equals 10 meters per second squared, height equals 2.1 meters, and when you solve, you find that the velocity is equal to 6.8 meters per second. We can use our knowledge of forces to determine the force exerted on Kitty by Catherine which made her fall. To solve for the force exerted on an object, you use sigma f equals mass times acceleration. Kitty's mass is 7.5 kilograms, and we have to solve for the acceleration. She was initially at rest and accelerated to a velocity of 1.43 meters per second in 0.1 seconds. Velocity is equal to the initial velocity plus acceleration times time. This formula can be manipulated to read velocity minus initial velocity divided by time equals acceleration. Since the initial velocity is 0, you're left with velocity divided by time equals acceleration. Since her velocity was 0.43 meters per second and the time was 0.1 second, you find that acceleration is equal to 14.3 meters per second squared. Now you can go back to the force formula. Force equals mass times acceleration. So, the force exerted on Kitty is equal to 7.5 kilograms times 14.3 meters per second squared, which is 107.25 newtons.
Kitty jumps at a 45-degree angle. Once you find out that delta x equals 1 meter and time equals 0.8 seconds, you get to write out your x, y up, y down chart. Find that you go up 0.4 meters using delta y, which is equal to 1/2 at squared. Use that formula to solve for the initial velocity as y goes up. Use v equals vo plus at and manipulate it to v minus at equals vo. Plug the numbers in and get 4 meters per second. Because of the 45-degree angle, the x and y components are equal, so initial velocity of x is 4 meters per second. You can find initial velocity of Kitty using the Pythagorean theorem, a squared plus b squared equals c squared, which gives you radical 32 as your answer.